Good morning, students. Previous lecture we will learn about conducting system of human heart, then stroke volume, cardiac output, what is systole and diastole. Today we will learn about cardiac cycle of human heart. Cardiac cycle of human heart. What is cardiac cycle, or define the term cardiac cycle? Cardiac cycle, the events associated with one heartbeat. Cardiac cycle is defined as the events associated with one heartbeat is called cardiac cycle. Definition of cardiac cycle is the events associated with one heartbeat is called cardiac cycle. Cardiac cycle is completed. One cardiac cycle is completed in 0.8 second. Cardiac cycle is completed in 0.8 second. One heartbeat is equal to a cardiac cycle. One heartbeat is equal to a cardiac cycle. So, number of normal heartbeat 70 to 75 per minute. So, number of normal heartbeat 70 to 75 per minute. Averagely 72 per minute. Averagely normal heartbeat is 72 per minute. Then next, a cardiac cycle which involves three phases or three events. A cardiac cycle which involves three phases or three events. First is the atrial systole, second is the ventricular systole, and third is the joint diastole. Means atrial systole means atrial contraction, ventricular systole means ventricular contraction, and joint diastole means both chambers are in relaxed state or in relaxed condition. The cardiac cycle is equal to atrial systole plus ventricular systole plus joint diastole. It's called as the cardiac cycle. Then next, phases of cardiac cycle. First phase, joint diastole, or which is also known as complete diastole. Complete diastole. It lasts about 0.4 seconds. Joint diastole or complete diastole lasts about 0.4 second. Then second phase or second event of cardiac cycle is atrial systole. Second phase is the atrial systole, which lasts about 0.1 second. Atrial systole lasts about 0.1 second. And then third phase is the ventricular systole. Third phase is the ventricular systole. It lasts about 0.3 seconds. Ventricular systole which lasts about 0.3 seconds. Then the first phase, joint diastole or complete diastole. Joint diastole or complete diastole. Joint diastole or complete diastole. In this phase, firstly all chambers of heart in relaxed state. In first phase, joint diastole phase or complete diastole phase, firstly all chambers of heart are in relaxed state. Then when the tricuspid and bicuspid valves open, when the tricuspid and bicuspid valves open, blood from pulmonary vein, when the tricuspid and bicuspid valves open, blood from pulmonary vein and vena cava, pulmonary vein and vena cava flows into left and right ventricles, left and right ventricles respectively, through left and right atria, through left and right atria. Then semilunar valves are closed at this stage. In the joint diastole or complete diastole, semilunar valves are closed at this stage. Joint diastole lasts for 0.4 seconds. Joint diastole lasts for 0.4 seconds. This is the first phase of cardiac cycle, or this is the first event of cardiac cycle. Then second phase or second event of cardiac cycle is the atrial systole. Is the atrial systole, or which is also called as auricular systole. Atrial systole, or which is also called as auricular systole. In this phase or in this event, the SA node generates an action potential. The SA node generates an action potential. It stimulates both the atria. It stimulates both the atria to undergo contract. Both the atria, that is the right and left atria, to undergo contraction. This increases the flow of blood. This increases the flow of blood into the ventricles. Atrial systole lasts for 0.1 second. 0.1 second. Atrial systole lasts for 0.1 second. And atrial diastole is for 0.7 second. See, atrial systole 0.1 second and atrial diastole is for 0.7 second. This is the second phase of or second event of cardiac cycle. Then third phase or third event of cardiac cycle is ventricular systole. Third phase is the ventricular systole. It causes contraction of ventricles. It causes contraction of ventricles, or which is also called as the ventricular systole, which is also called as the ventricular systole. Then during this phase, the atria undergoes diastole, means relaxed state. During this, the atria undergoes diastole, means relaxed state or relaxed condition. The ventricular systole increases. The ventricular systole increases the ventricular pressure. The ventricular systole increases the ventricular pressure. This phase causes the following events. The ventricular systole phase causes the following events. First event is the closure of tricuspid and bicuspid valves. First event, closure of tricuspid and bicuspid valves due to attempted backflow of blood. Due to attempted backflow of blood in the atria. Then second event is semi-lunar valves open. Second event is the semi-lunar valves open. So deoxygenated blood enters. Due to the opening of semi-lunar valves, deoxygenated blood enters the pulmonary artery. Deoxygenated blood enters to the pulmonary artery from right ventricle. And oxygenated blood enters. The aorta from left ventricle. The oxygenated blood enters the aorta from left ventricle. The ventricle relaxes and ventricular pressure falls. The ventricle relaxes and ventricular pressure falls. It causes the following events. First is the closure of semi-lunar valves. Second event is tricuspid and bicuspid valves. Second is the tricuspid and bicuspid valves are open. First event is the closure of semi-lunar valves. Second event is the tricuspid and bicuspid valves are open. And third event is ventricles and atria. Third event is the ventricles and atria again undergo joint diastole. Above these processes are repeated. This is the cardiac cycle and the phases which is involved in a cardiac cycle. Then next point is the heart sound. Next point is the heart sound. During each cardiac cycle, two prominent sounds are produced. During each cardiac cycle, two prominent sounds are produced. First sound, which is called as the love sound. First sound, which is called as the love sound. Love sound is due to love sound produced due to closure of tricuspid and bicuspid valves. First sound, that is the love sound, which is produced due to closure of tricuspid and bicuspid valves. Then second sound is the dove sound. Second sound is the dove sound, which is produced due to closure of the semi-lunar valves. Which is due to closure of the semi-lunar valves. These are two prominent sounds. First sound is the love sound and second sound is the dove sound. Then one heartbeat is equal to a love sound plus a dove sound. One heartbeat is equal to a love sound plus a dove sound. Then next point is the pulse. Next point is the pulse. What is pulse? Pulse is a pressure wave. Pulse is a pressure wave that travels through. Pulse is a pressure wave that travels through the arteries. That travels through the arteries after each ventricular systole. After each ventricular systole. The radial artery at the wrist. Radial artery at the wrist is commonly used to feel the pulse. It's commonly used to feel the pulse. Pulse rate is the same. Pulse rate is the same as that of heart rate. Pulse rate is the same as that of the heart rate. 72 beats per minute. 72 beats per minute. It is the strongest in arteries. It is strongest in arteries. Closer to the heart. It is strongest in the arteries, closer to the heart, and becomes weak in arteries. Becomes weak in arteries away from the heart. Away from the heart. Then next, what is tachycardia? Next point is the tachycardia. What is tachycardia? Pulse rate higher than normal. What is tachycardia? Tachycardia is the pulse rate higher than normal, means above 100 beats per minute. Pulse rate higher means above 100 beats per minute. Then second, what is bradycardia? Second, what is bradycardia? Pulse rate is a slower. In bradycardia, pulse rate is a slower than the normal. Pulse rate is a slower than the normal, below 60 beats per minute. Slower than normal means below 60 beats per minute is called bradycardia. In this lecture, we learn cardiac cycle, then phases or events of cardiac cycle, then heart sounds, two prominent heart sounds. First is the love, second is the dove, and then pulse and the